Okay, on number 4, it says there's two positive numbers a and b. That means a and b are greater than 0. It satisfies these equations over here. It says compute 1 over a plus 1 over b. So I need to go to the whiteboard and write down what they've given me, and then write down what they've asked for. So what have they given me? And let's write this down. It's number 4. In number 4, you've been given, that 2 plus log base 2 of a is 3 plus log base 3 of b equals log base 6 a plus b. What they asked for, what's the value of 1 over a plus 1 over b? That's their question, right? The way I'm going to do this over here is going to try to take these 3 separate statements. Like, for example, 2 plus log base 2 of a. I'm going to try to simplify that. And if I did that, I would try to write it as a single log, by the way. So log base 2 of 4. Now, I realize 4 is 2 squared, so that's going to give you 2. That's going to give you plus log base 2 of a. And I can combine that together, by the way. That would give me log base 2 of 4a. I'm going to say that this thing is just equal to some number, all right? So what I'm going to write down now is that, let me see what I'm going to write down. I'm going to write down, and let's go to the next one, and I'll write that down later. So 3 plus log base 3 of b is going to be log base 3, and that's going to be 3 cubed now. That's going to give you 3, by the way, plus log base 3 of b. And what does that equal to? Rules of logs, by the way. Log base 3 of, I'm going to say 3 cubed is 27, so 27b. Again, you may look at this and say, I wonder where it's going. And I'm wondering where it's going now too, but I think the last guy I could write down, there's not much I could do about that. That's just log base 6. And that would be a plus b. All right? What do I know about all these 3 things? They're all the same thing. Every single guy's the same thing. So what I'm going to do is, logs can be difficult. I'm going to write it as an exponential problem. And let me put this down one step at a time. So I'm going to talk about these are all equal. That this is equal to this. And this. They're not the same base, by the way. That's a problem for me. So what I'm going to do is rewrite them separately. I'm going to say they're all the same thing. They're all x. So the first guy, if I rewrote this in exponential, the 4a, right, would equal 2 raised to the power x. And this guy over here, let me write this down for you, it would be 27b would equal 3 to the x. All right? And this guy over here, let's just think about that. That would be a plus b would equal 6 to the x. All right? Maybe simplify a little bit further. I'm going to say a is 2 to the x over 4. And I'm going to say b is 3 to the x over 27. Again, we could simplify that if you want. I'm not sure if it's important at this stage over here. And I'm going to say that not much I can do about this. This is just simply a plus b equals 6 to the x. All right? Now someone said, what was the question? The question is, what's 1 over a plus 1 over b? What's that equal to? Well, what I'm going to do is I'm going to try to simplify this. And I'm going to say a common denominator would be ab. That's a product of a and b. And then it would be a plus b. And I can write this down. I mean, this and this are identical. So what's a plus b? It's 6 to the x. What's a times b? I can write that down too. It's 2 to the x over 4 times 3 to the x over 27, right? And this is what, I can write this down now. 1 over a plus 1 over b is the same thing as 6 to the x. That's this right over here. Let's just do the bottom. What's the bottom going to be? Well, that's 6 to the x, right? Because 2 to the x times 3 to the x is really something as 2 times 3 to the x power, which is 6 to the x. And 4 times 27, that's 80 and 28, which is 108. Well, let me rewrite this. This is 6 to the x, divide by 6 to the x over 108. This is 6 to the x times 108 over 6 to the x. This cancels off. We're left off with 108. And that's our answer. Thank you.